Alright guys, I'm going to try to do each of these problems pretty quickly, so if you need more explanation, just come see me in class and we can talk about it. So first question was a velocity and position question, and we have to remember here that velocity is equal to the derivative of position, and vice versa, that the integral of velocity is the position. So in this case, since we're starting with velocity and it's asking us for position, we're going to need to use the integral of v of t dt is equal to the position. Now we're going from 0 to 8, so from 0 to 8, and we have to remember the first fundamental theorem of calculus is, this is going to be the position at 8 minus the position at 0. And then it also gave us kind of this initial condition. It said at time equals 0, the bug is 4 meters above the ground. That's a position. So we have kind of an initial condition of 0 is equal to 4 meters. That's going to be this right here. So now we do the integral. That's going to be from the graph. So we need to kind of break this up and use geometry. So we have this first triangle. Base times height, 2 times 3 is 6 over 2, right? Base times height over 2, so that's 3. Then base times height, 2 times 3 is 6. Again, 2 times 3 divided by 2 is 3. And this one has base of 2, height of 1. 2 times 1 over 2 is 1, but it's below the axis, so this is negative 1. Then we add those up. 3 plus 6 is 9, plus 3 is 12, minus 1 is 11. So we get 11 is equal to the position at 8 minus 4, right, our initial condition, add over, and we get 15. So that was a net change problem. Next we have the area between two graphs. And so, basically this is area equals the integral from a to b of the top minus the bottom dx, or right minus left, but in this case we have y, so we'll do top minus bottom. To get these endpoints, you have to set these two graphs equal to each other. So x squared plus 1 equals 5. Subtract 1 from both sides, we get x squared equals 4. Square root, we get x equals plus or minus 2. So now we know the endpoints are negative 2 and positive 2. But to figure out which one is top and which one is bottom, you have a couple choices. The first choice would be to graph these. And in this case, we'd kind of have to graph it by hand, which you could do. Right, 1, 2, 3, 4, 5. And then x squared plus 1. So we know that, 5 is on top. The second thing you could do is you could pick an endpoint in between negative 2 and 2. So I like to pick 0 if I can, and plug that in. If we plug in 0, we get y equals 0 plus 1 is 1. Plug in 0 here, it's still 5. So that's on top. Either way you do it's fine. So now we have 5 minus. Now be careful, I saw a couple people doing x squared plus 1 like that. But we have to subtract the entire thing, so you want to put a parenthesis there. So 5 minus all of x squared plus 1 dx. Now you can combine like terms and make 5 minus 1 4, or you can just basically integrate all three of those individually. I'm going to combine like terms, so 5 minus 1 is 4, so we get area equals the integral from negative 2 to positive 2 of 4 minus x squared dx. Then we integrate that. Area equals 4x minus x cubed divided by 3 from negative 2 to positive 2. Plug in and we get the area is equal to 4 times 2 is 8 minus 8 thirds minus 4 times negative 2 is negative 8 minus, that's negative 8 thirds. And now it's just basically simplifying. 8 minus negative 8 is 16. Negative 8 thirds minus 8 thirds is negative 16 thirds. And that gives us 48 over 3 minus 16 over 3, which is 32 divided by 3. Alright, next question we see is a volume question. What I saw a couple people get trapped on this one by is it's revolved about the y-axis. You have to be careful there. So we're revolving it around the y-axis, which means that we need to change these to be x equals, okay? So we know that instead of having y equals radical x, since we're revolving around the y-axis, we need to solve for x, and we get x equals y squared. So this graph still looks like this, and we're going from now 0 to 2. So we're revolving this area here around the y-axis. So our endpoints will be 0 and 2, right? We start off here, and we get volume equals pi times the integral from a to b, which in this case is 0 to 2, of y squared dy. Then we get volume equals pi times y cubed over 3 from 0 to 2, which will be, I'm going to factor out the pi, 2 cubed is 8 thirds minus 0 thirds, and that's just 8 pi over 3. Alright, the next question is a differential equations question with an initial condition. So we have dy dx equals y, and then they want us to figure out what is y of e. So in this case we need to multiply both sides by dx, and we'll divide both sides by y, or you could cross multiply, but basically we're going to end up with dy over y equals dx. Now we integrate both sides. I'm going to write this up here. Integral of 1 over y is the ln of y equals, and then the integral of just 1 dx is x, but since we don't have endpoints we need to put plus c. So we have ln of y equals x plus c, and then we want to figure out y, so we need to solve for y, so we're going to do e to the power of both sides. Y equals e to the x plus c, and then we can bring this plus c down to get y equals c e to the x. Now we plug in our initial condition, and we have 1 equals c e to the 0, which is just 1. So 1 is equal to c. So now we come back to this right here and we plug in c, and we get y equals 1 e to the x. And now it said find the value of y of e. So now we just plug in e for x. We get y equals e to the power of e. So choice A. Alright, next question is average value. And so for this we need to remember that the average value formula is 1 over b minus a times the integral from a to b of f of x. So in this case we're going to have 1 over e minus 1 integral from 1 to e of 1 over x dx. And I knew that 1 was on the bottom and e was up top for two reasons. First, it said from 1 to e. Second, we know e is 2.7 something, so it's going to be bigger. Now that gives us 1 over e minus 1. Integral of 1 over x is the ln of x from 1 to e, and that gives us 1 over e minus 1 times ln of e is 1 minus ln of 1 is 0. So that's 1 and that's 0. So we just have 1 over e minus 1 times 1. So that's choice E. Next question, we have volume of a solid generated by revolving the region enclosed. So another volume. This time we're revolving it around the x-axis. So we want to solve for y, so we already have that. Now in this case, to get the endpoint, so volume equals pi integral from a to b of big R squared minus little r squared dx. So to get our endpoints, we set these equal to each other. 3x squared equals 6x. I'll subtract 6x. 3x squared minus 6x equals 0. Factor out 3x. And we have x equals 0 and 2. So we could cross out choice A. And now we need to know which one's on top, which one's on bottom. So you could either graph these, or you could plug in something in the middle. So in the middle of 0 and 2 is 1. So if I plug in 1 here, I get 3. Plug in 1 here, I get 6. So I know this one is on top. So we're going to have 6x squared minus 3x squared all squared dx. 6x squared is 36x squared, and then minus 3 squared is 9, x squared squared is x to the 4th. And so that was choice D. Alright, 7. I told you guys to not worry about 7. We're kind of skipping that one. So we'll move on to 8. And 8, again, we have dy dx with an initial condition right here. So we have to integrate this differential equation. So we'll cross multiply. We get y dy equals x squared sine of x squared dx. Now we integrate both sides. Integral of y is y squared over 2 equals, now in this case we have to do u substitution. So our u is going to be x squared. Du would be 2x dx. Now we want to get dx by itself, so we'll divide by 2x. So we have du over 2x, or actually over 2, is equal to x dx, right? Because we already have this x dx here. So now we get y squared over 2 is equal to the integral of sine u du, and then y squared divided by 2 is equal to integral of sine is negative cosine, u is x squared, and then plus c. Now we want to solve for y, right? F of x is like y. So we can either multiply by 2 here, or we can plug in our point and solve for c. It doesn't really matter when we solve for c. I'm going to go ahead and just multiply both sides by 2. So I get y squared equals negative cosine of x squared plus 2 times c is 2c, or we could just call this, again, like another c, or c prime if we want. If you solved right here, you'll have a c, but once you multiply, you'll get this new c, so it doesn't really matter where you plug it in. And then I'm going to square root, take the square root of both sides, and I'm going to write down here, y equals the square root of c minus cosine squared, or sorry, cosine of x squared. Now we'll plug in that 0.10. So 1 is equal to radical c prime minus cosine of x squared. And now I'm solving for x, so I could square both sides. And I get 1 equals square root, oh no, we squared it, of 1 minus cosine of x squared. Subtract 1 from both sides, we get 0 equals negative cosine of x squared. Oh, you know what? I think I messed this up, huh? I plugged in, yeah, sorry guys, I plugged in for C. So that's my fault. We're plugging in, so just ignore what I just did with that. We're plugging in the point 0, 1. So that's 0 for x. That was my fault. 0 for x and 1 for y. So we're just going to plug that in right here. 1, 0. And that's going to give me 1 equals square root of c minus cosine of 0 is 1. So now, you know, if we square both sides, we get 1 equals c minus 1. So 2 is equal to c. And then we plug that, 2 equals c, back there. And so we'll have y equals 2 minus cosine of x squared. So that's choice A. Alright, next question we have, it says, consider all right circular cylinders for which the sum of the height and the circumference is 30 centimeters. So I'm just going to go ahead and write that h plus circumference is 2 pi r equals 30. Then it says, what is the radius of the one with the maximum volume? Okay, as soon as we see that word maximum, we're thinking optimization, right? Take the derivative, set it equal to 0. And we know volume of a cylinder is pi r squared h. Now, we want to know what is the radius, right? So we need to kind of get rid of this h term. And the way we're going to do that is with this initial condition it gave us of height plus 2 pi r equals 30. So we need to just solve for height. So h equals 30 minus 2 pi r. And then we can plug that into the volume. So a volume equals pi r squared times 30 minus 2 pi r. And that can give us volume equals 30 pi r squared minus 2 pi squared r cubed. Now we're going to take the derivative of this and set it equal to 0 so we can maximize it. So derivative would be 60 pi r minus 6 pi squared r squared, and we're going to set that equal to 0. Then we can factor out 6 pi r, and we get 10 minus pi r equals 0. So we would have r is equal to 0, or 10 minus pi r equals 0. Solve that, and we get r is equal to 10 divided by pi. So we have two choices. R is 0 or r is 10 over pi. The way you would determine that is kind of, on that number line 0, 10 over pi. Figure out when it's increasing and decreasing to get the max. Or you could be smart about looking at the answer choices. There's no 0, so 0 is the minimum. 10 over pi is the maximum. All right, next question we have is base of a solid in the first quadrant, and then it's telling you each section of this is a square, so each plane section perpendicular to this is a square. So this is kind of our cross section, and so we know that formula is volume is equal to the integral of area, and in this case our area is a square, so area of a square is just side squared. Now we have the volume is of 4x squared, x equals 1, and the x-axis. Okay, so in this case, if you graph that, right, 4x squared, x equals 1, and the x-axis, that's going to be this right here. It also told you the first quadrant. So you know our endpoints are going to go from 0 to 1. And so this will be volume equals the integral from 0 to 1 of 4x squared squared dx. That's going to be the integral from 0 to 1 of 16x to the 4th power dx, which is 16x to the 5th power over 5 from 0 to 1. And that's 16 over 5 minus 0, or just 16 over 5. Alright, our next question asked what is the area of the region bounded by these two curves. So area, right? Area equals integral of top minus bottom dx from a to b. And to figure out those endpoints, we have to set these equal to each other. So we have negative x squared plus x plus 6 equals 4. I'm going to try to get this x positive, so I'm going to move everything to the right side. So 0 equals x squared minus x minus 2. Factor that, we get x minus 2, x plus 1. So that's going to give us x equals 2 and negative 1. So this is going to be the area from negative 1 to positive 2. And now if we plug in like 0 again, that's 4, right? A point in between these is 0. And this one is 6. So this is our top. And then we have negative x squared plus x plus 6 minus 4 dx. I'll combine my like terms, and that gives me the integral of negative x squared plus x plus 2 dx. We integrate that, we get negative x cubed divided by 3 plus x squared divided by 2 plus 2x from negative 1 to positive 2. And then we plug in positive 2, we get negative 8 thirds plus 2 times 2 squared is 4 over 2 is 2 plus 4 minus, plug in negative 1, we get negative 1, but another negative, so we get 1 third plus 1 half minus 2. Okay, now let's just, all of our numbers, 2 plus 4 is 6, minus negative 2 is 8, then negative 8 thirds plus minus 1 third is minus 9 over 3, which is just 3, so 8 minus 3, and then minus 1 half, right? Distribute the negative. That's 5 minus a half, which is 4 and a half, or 9 halves. Choice C. Alright, and then the last question was definitely the most difficult question on here. It said the number of bacteria is growing at a rate of 3,000 e to the 2t divided by 5. This is kind of like that temperature problem you guys saw in one of those videos. But the key here is it's growing at a rate. So anytime you see that word rate, you think dy dx, or in this case for time dy dt equals 3,000 e to the 2t over 5. So it didn't tell you normally, like on these, a lot of times it'll say it's proportional to something, and you know, then that's when we can do y equals y naught e to the kt. In this case, it didn't tell us that. It told us it's growing at this rate, so we need to start off with the derivative. So now we multiply both sides by dt, and we get dy equals 3,000 e to the 2t over 5 dt. Integrate both sides. Y equals, this is going to be u substitution, u equals 2t over 5 du equals 2/5 dt. So if I multiply both sides by 5/2, we get dt is equal to 5/2 du. So this is the integral of 3,000 e to the u times 5/2 du. Okay, that's going to give me y equals 3,000 times 5/2 ends up being 7,500. And then the integral of e to the u is e to the u. And we plug in u as 2t over 5 and then plus c. Notice that this plus c is at the end. It's not up here with the e because we never did ln or anything like that. I'm going to erase this so I have a little more room. And while I'm doing that, our next step, so we have this equation for y now. And our next step is going to be to plug in that initial condition of at time is 0, the bacteria is 7,500. So we have y equals 7,500 e to the 2t times 0. So basically e to the 0 plus c, and then at this, when we plug in 0, we get number of bacteria 7,500, which is our y. So 7,500 equals 7,500 e to the 0 plus c. That's 1. So subtract 7,500 and we get 0 equals c. That we're going to plug in to our equation. So our new equation is y equals 7,500 e to the 2t over 5 plus 0, or just right there. Now we want to find the number of bacteria at time equals 5. So we plug in 5. And we see that those 5's cancel, so we get 7,500 e squared. Choice C. So there's all of that. I know that took a little bit of time, but hopefully you got all the questions answered that you needed. And if you watch this entire video and you're still watching, just tell me, the answer is, just say that the answer is not purple to me quietly sometime this upcoming week, and I'll give you some extra credit.